We want to find the quadratic function with the given vertex passing through the given point. It's always a good idea when you have enough information to sketch a graph. So if this is the point 3, 2, we have the point over here, negative 3, negative 2. Is there a quadratic function with a vertex here that goes through this point, and if so, can you draw its graph? Well, I can easily draw a parabola with a vertex here. Now, if the vertex is here, it's got to start out kind of horizontal and then go down through this point, and this is going to be an axis of symmetry, so it's going to do this, right? So I can already estimate, I mean, if this is 3, here's 1, 2, 3, here's 1, 2, 3, that we're going to have a 0 here close to negative 2, and we're going to have a 0 over here at about 4, 5, 6 or 7. So I can kind of estimate where my zeros are, can't I? Now, I don't know if I drew a good parabola or not, okay? I mean, it's not too bad, so not too far off, but we can actually check my drawing by, first of all, figuring out the formula for this thing, and then finding the zeros. Now, the question didn't ask you to do all that, but it asked you to find the general form of this quadratic, right?
How do you know that that would be the vertex?
It says so.
Oh, it does how
It says find a parabola with a vertex at this point and going through this point.
Okay, yeah, you're right.
Okay, so now what we need to do here, the general form I'm sorry. I believe your text calls it the standard form of a quadratic is this.
You got general form on 8.
It's this.
Standard
Okay? Now that's exactly what we did when we started.
y equals
Okay? We got a parabola in this form by figuring out the vertical shift, which is 0.015, the horizontal shift, which is 80, and the vertical shift, which was negative 20. I say vertical shift, vertical stretch, which would be 0.015, right? So we've already seen an example of this. Okay? Well, there's your standard form. And your vertex is HK, right? So for this parabola, okay, for vertex 3, 2, we get y equals a times x minus 3 squared plus 2. Okay? Now what is it we still need to find? To find the function, we need to find the value of a, right? But we know the value is vector k because I told you what the vertex was. Make sense? Now, if x equals negative 3, y equals negative 2. How do I know that? Because this point is on the parabola, right? So when x is negative 3, y has to be negative 2. So we just plug those values in, and x is negative 3. And we solve this for a. Okay? That's pretty easy. That's going to be 36. And you're going to subtract 2 from both sides. So you're going to get a equals negative 1/9. Now, everybody can solve this equation for a. And if you do it right, I think you get negative 1/9. Okay? If I'm wrong, solve it right and fix what I say. So, your function is y equals negative 1/9 times x minus 3 squared plus 2. Right? We can take this and square that x minus 3 using the distributive law as opposed to superstition. Okay? And then multiply through by the 1/9, and we have an at squared plus bt plus c form.
Alright, so Professor Smith, you put the standard form of quadratic